And I just
We are
unmuted
now
him.
recording, so I'm going to kick this immediately to the great Santini to give us some wisdom on teaching techniques for CAN bus and multiplexing.
Well, the first thing is wisdom. I'm not sure that's anyway. It's nice to be here, guys. I appreciate it, and maybe if there's a girl or two in the group too, that works out well. Um, just a couple of things before I really get started. This was originally designed as a couple-hour presentation, and so we're gonna go on till 4 today, and during no, not really, and during that time, it was reasonably successful, and then a couple of years ago, I changed it over and made it hands-on, and that's the way I really like to teach. Now, obviously, this makes it a little bit difficult. What was on my mind was that I would be using the MP 1918, which if I can, Jimmy, why are you up here?
You need to actually share the
I
document that you want to share instead
I
of.
know I'm trying to, but
So hit stop sharing and then share. Go when it, then click it again and click your PowerPoint.
got it.
Did you share your desktop,
There
Al?
you go.
Okay, this is the MP 1918. For those that aren't familiar with it, and I don't intend this to be a sales pitch, but it's a very interesting trainer, one which I am fascinated with, especially using it for teaching. It's got 4 modules: an input, an engine, a cluster, and an output. And we have the students wire it and go through a diagnosis. So it works out pretty well. But anyway, this again is not intended as a sales pitch. What I'm going to do today is to try to do very, very simple basics, and then go into tools from a simple standpoint, and then go into diagnosis. I think there are not as many people teaching CAN bus as we really ought to have, and that's part of my feeling. I think when you start teaching, there's a couple of things that you should keep in mind. If you look at a lot of the literature that's out there, it's way too complicated. I mean, there's all this about all these different systems. There's one program I looked at for an hour about identifying what the gateway is or where it is, and it's like, I asked this question here, you know, do they really need? I'm a believer in need to know and nice to know, and the rest of it's all bullshit. So, does the student need to know what module? I don't think he does, and I would skip it. Obviously, especially in 27 minutes that I have left, there's no way I'm going to cover all the variations on CAN, nor do I think that you should be trying to do the same thing. There's so many variations out there. Look out in your parking lot, see what you have available, and that's what you teach. Okay? I think the use of a breakout box at the DLC is an absolute imperative. And it's for 2 reasons. The first reason being you're trying to protect the DLC. The breakout boxes that are out there have got way more robust connections, and the DLC is made out of recycled chewing gum wrappers. So, I mean, you get a student who starts probing the DLC, and before you know it, you can drive a small truck through the pin opening. So, the breakout box is obviously a real important thing to do. I find the KISS philosophy of keep it simple, stupid works exceptionally well for me, and I think if you take it from that standpoint, it'll make more sense, and the students will follow along pretty well. I usually start with a comparison of individual data transfer. And let me stop it right now and make comment here about what you're looking at. Everything that I'm going to show on the screen is in 2 places. First off, if you go to consulab.com and go to the resources page, you will find there are 2 CAN bus presentations. One of them is a handout. That's what this comes from. And the other one is the actual 2.5 hour PowerPoint. and feel free to use it. Don't abuse it though, and don't sell it or anything else, but use it. So that's where this comes from, and that's obviously available to everybody. Anyway, I usually start with this individual data transfer because I think it makes sense to a student. We've spent time talking about, let me get a pointer up here. We've spent time talking about all systems need a battery and all systems need a ground, and there will be some kind of a load somewhere. So in this particular case, it makes a lot of sense to show students that if we close the backup light switch, well, then the backup lights go on. Why do they go on? And quiz the student. Why did the lights go on? And the other thing that I'll do sometimes is I'll pull this fuse, or I'll remove this ground on the diagram, and then say, okay, when I close this switch, do the lights go on? And the obvious answer is no. So try to get the student to back up in his knowledge and understand the basics of battery, ground, and load and control. And then, if we take a look at each one of them and then say, okay, now, if this is a car in the 1990s, well, then what do we have for a current car? And what we have is a very simplified diagram of CAN. Now, I know the first time you look at this, especially when you compare it to this, you say, wow, this is simplified? What in the hell is Al talking about? Anyway, what I mean by this is data transfer. And that's the thing, you go back to your first diagram and you say, now, how did we get data transfer here? Well, there really is no data transfer. We just switched on power or switched on ground to turn something on. Whereas here, then we have to emphasize again that there's two modules here. We have an input module, we have an output module. Both of them have battery. And then we have another battery lead in this particular case that feeds the switches to the input module. And how does the output module get the information? Well, it gets it along the CAN bus. In this particular case, it's a high-speed CAN, like pin 6 and 14 in the DLC. So once the output module sees the information from the input, then it turns on the backup lights if the backup light switch is actually what has been closed. Okay, I like to start with this because I think this makes a lot of sense to students. It's not that it's simpler, it's just that this is how it actually is going to function. And then when I'm dealing with the MP1918, I put up a diagram, and I didn't bother to put it in this real abbreviated presentation today, but I put another one up that has the four modules, has the input, the engine, the cluster, and the output module on the MP1918. And the students can see that every one of those modules needs power and ground to start with. So then I have the students or the automotive teachers wire that up, okay? And once we get the idea across to the student that it takes power, it takes ground, and it takes signal to be able to get any output or any input into the system, it makes it a reasonable thing for them to be able to go into how do we communicate. And that's another thing. In other words, we have to get the students to the point where they recognize they can't use a 12-volt test light. They can't look at the system. They can look at the system to see if it's functioning, but what does it really take? Well, the first item that I'm always going to list is going to be the breakout box. And again, I'm doing that to protect the system, okay? A multimeter, a DSO, and a scanner. These are the four basic tools that you need to get across a very simple diagnostic procedure. I think we all ought to be teaching this diagnostic procedure because it's something the student can do at the DLC. Now, back up just one small little bit here. Realize that the pins in the connectors for the various modules, again, are made out of recycled chewing gum wrappers. You cannot connect and disconnect them more than 3, 4, 5 times, and then the connector has a bunch of opens and begins to see fretting. And once it sees fretting, then it's just absolutely not going to work that well. So we have to get the students to recognize that this is a diagnostic procedure that you're going to teach them, but it's not the entire diagnostic procedure, because when they're out in the field, after they've done use these 4 tools, they would have to go one step further, and that is to go out to modules and unplug and replug and do things like that, which you're not going to try to teach them in a classroom situation. Okay, now I know it looks like I've had a lot of caffeine because it's jumping all over the place, but look at your that light. Okay, on 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and off. What does this really show? And this is something that students need to see and need to experience. Now, obviously, if you have a breakout box, such as this one, Line Spy, and it's got the indicator lamps, that pin 6 that you see up there, that light went on when there was data. So in other words, when there's communication amongst the various modules on the automobile, that light is flickering extremely fast, and that's on pin 6. Some of the newer ones have got on all of the pins have got various LEDs. This one just has it on the CAN pin 6, and that works. That's good enough. So we use this for a variety of reasons. Again, one of the ways was to be able to protect the system, and the second is, in this particular case, to be able to note when the system is alive. Now, why do we want to do that? Well, the student needs to be able to see that the system is awake or alive, because that's how the system communicates. If there is some system communication that goes on for a period of time without any inputs, the system is going to go to sleep. And the student needs to recognize that they can't disconnect anything with CAN awake. So get the students to look at the light and say, hey, the light's on, I can't do anything. And the other thing is, they have to realize that to get the light off, they have to turn inputs off. So they can't be opening and closing doors and moving ignition key, playing with the radio, or any of the other things, because that keeps the system awake. Okay?
Al?
Yes?
Excuse me, just a question that someone may be thinking about, and don't take a lot of time to answer it, but if there's a fault in the system, could it keep the CAN awake even though it should be going to sleep?
Yes.
Okay,
how's that? Is that a fast enough answer? Okay.
That's very good.
That's, and the other thing is, a fault in the system can prevent the system from becoming awake and going, so it's in either end. Okay. Some of these breakout boxes allow you to connect the scanner in, and that's not a bad idea. And again, we need to be teaching more than just diagnostic trouble codes. I mean, we need to teach that, but we need to teach more. So what's a decent, simple process? Well, the process, it actually is extremely simple, and that's what I'm going to go through today. For no communication or no start, we pull the battery, and we use an ohmmeter on the high speed. When we're done with that, we connect the battery. Now, people say, oh, wait a minute, why are you using an old device like a multimeter? Well, it still is one of the best ways to be able to determine whether the system can have the ability to be able to function. It doesn't tell you whether it's functioning or not. It tells you whether it has the ability to be able to function. Once we're done with that, we connect the battery, and then we switch to a 2-channel DSO, at least a 2-channel. If you have 4 or more, that's fine, but at least a 2-channel. And we use one of the channels. We look for a wake-up signal, and then we look for a mirror image, and I'm going to do all this, and then we scan for available modules or module status. So let's start with this. Okay, first thing we do, disconnect the battery. Now, by the way, if you're using one of our trainers, you don't necessarily have to disconnect the battery. You can unplug, because the power is there. You can switch the power off and do the same thing. And the other thing is, on many vehicles, you can unplug some of the module fuses and get the same thing. But the battery's got to be out of the system. Otherwise, you wind up with a goofy thing. Now, remember, there's 220 ohm resistors that are wired in parallel. Ohm's law says you're going to have around 60 ohms. So this is a resistance value of 61.4 ohms that you can see here. Some people say, oh, if you have the battery connected, you're going to blow your multimeter. No, you're not going to do anything. You're going to get an inaccurate reading. You're not going to damage the multimeter. You don't have to worry about the student doing that, unless, of course, they put it into a current setting, a real low setting, then they may pop a fuse. But if they're on ohms, you're going to measure with the battery disconnected, or you're going to get an inaccurate reading. You're not going to do any damage anywhere, okay? And the student needs to know that what he's really doing is he's measuring the bus resistance. Now, at the beginning of a full-fledged class, I would go through the various definitions, and one of them would be the bus. And I start out and I say it's a big rolling device that carries people. And no, wait a minute. It's a connection. And then on the MP 1918, we've got yellow and green wires, and those yellow and green wires are connected to the bus, which is just a common connection point. Just like you could actually call the ground on an automobile the ground bus. It really isn't, but we could call it that because all things connect to it. It's basically the same thing. You're trying to determine whether there is a pathway. And the obvious thing for a student to recognize is you really don't have a lot of different choices, but one of them is 0 ohms. Well, if you have 0 ohms, you have an open circuit. And you're obviously not going to get any communication because you don't have a pathway. If you have 0 ohm, if you have an open circuit, I think I said 0 ohms. I didn't mean that. If you had infinity, you've got an open circuit. There is no pathway. If you had 0 ohms, you have a short. Again, there is a pathway, but not necessarily where you want it to go. Okay, I'm using pins 6 and 14, and here's a real one with the battery disconnected. This is an older Ford Focus, 61 ohms. It's not going to be exactly 60, but it'll be close to it, and that's the important thing. Now, this is a wake-up signal, and you can see from the top where it says Pico 6 Automotive. This is a GMC Acadia. It happens to be a 2011, and it's on pin 1. Now, pin 1 is the low speed. When you teach this, realize that the students should realize that they can see a wake-up signal on either low speed or on high speed, and it's basically the same signal. On many of the GMs, you get an exaggerated low speed, which you see right over here. And that exaggerated low speed allows you to set, see the gold square? So what I've done is I've set my trigger slightly higher than the actual packet of information we'll be running. Because it's slightly higher, then I can set the oscilloscope up for a single transfer of one pattern all the way across the screen, and you'll have nothing on the screen until you achieve the conditions that have been set by trigger. And then once trigger occurs.
Al, excuse me, Joe Hart is asking, can you see a wake-up signal on pin 6 and 14, or is it always on 6 and 14?
Well, now wait, you can see it on either 6, 14, or pin 1. Okay? On a GM, I like to use pin 1 because you see this exaggerated signal. And that's an easy one for the students. And this is in the handout, by the way, which you can download. It's an easy one for the students to say, well, look at this. These are packets of information. There's a break right there. That's one packet right there. And then here's another packet. Okay? So what happened before these packets of information is we had to wake up the system. And so how do we wake it up? We send a signal which is significantly higher and different from the actual packets of information. But the answer is you can see it on either high speed or low speed. On high speed, it typically is not that much greater. That's why I like to use low speed. Okay? If we have the students and the students can get an idea that there is a wake-up signal, why are we doing this? Well, think about this in sequence. We looked at the resistance value of the CAN bus. And we said, okay, it's 60 ohms, that's decent. Well, now we want to make sure that we actually put something through that CAN bus which wakes up all the modules. The modules have to be asleep, otherwise the battery's going to be dead the next morning when a person comes out. So we know the modules are supposed to go to sleep when we turn the key out and we lock the door and walk away from it in a matter of 15, 20 seconds, or as much as 5 minutes. The system will stay alive and be drawing current, okay? So when we go and we want to wake the system up after it's been asleep, how do we do it? Well, we have to have that 60 ohms, and then the second thing we have to have is we have to have a signal which comes from the gateway. And this is the only time when I emphasize the gateway. How do we get this whole thing started? We use the gateway. How do we communicate with the vehicle? We use the gateway. So the gateway does come into play, and in many cars we can't even figure out what it is. But anyway, it's there. Okay?
10 minutes. 10 minutes.
Yeah, I know. I got a timer going. Okay, I've done this before. Once we have the system and we realize the system is awake, then the next thing we want to do is we want to look for the mirror image. Now, I need to emphasize this. Why do we have a mirror image? Well, the whole system operates, a high-speed system, operates under the premise that there's going to be these two systems operating in conjunction with one another, and that's where we get this mirror image. When I teach this in a class, I usually borrow somebody's cell phone, and I hold two cell phones up to my ears, and I say one of them is one side, one of them is the other. And the nice thing about this is if one of these cell phones drops out, I still have the other one, which means if one of these signals disappears, this car, in theory, should start and should run. It might not run real well, and it also might not run any of the monitors. We found that in our Illinois emission groupings up here in Illinois. That's frequently, if one of the systems is down, you don't get the monitors to run, which means you don't set any DTCs, you don't set any check engine lights or anything else. If you look at this, though, you got to point out to students that there's some real obvious things. See how this, I got a nice big broad, stroke type of thing here. There it is. We have a little bit of a blurb right there. That same blurb is right there. If we go over here, we have a long pause. Now, by the way, that space right there might in fact be the end of a packet. I kind of doubt it, but it's possible that it is. But the important thing is it's a mirror image. And the mirror image is extremely important because it says the system is able to not only transmit, but receive. If we jump ahead, here's an image from a guy in Illinois, Jason Brennan, who determined that, and I'm not sure you can see it. Jimmy is kind of blocking it a little bit where he is here, but the text says no communication to the state testing equipment here. Now, is this a mirror image? Well, take a look at it. Okay, and this is a good example right here. What direction does this go? It goes down. What direction does this go? It goes down. It should have been going up. Okay, we have a blurb right there. I'm right below it. Does that blurb show here? Yes, but it's not proportional. This is not a mirror image. And this is what if we see, then the student has to recognize that the next thing he has to do, and you're not going to do it in classroom situation, the next thing you're going to do is you're going to take the student out and you're going to unplug modules. After you unplug modules, you're going to turn the key on and see if you go back to a mirror image. If you go back to a mirror image and you started with this one, well, then it means, hey, that module I just disconnected was a bad one. In this particular case, Jason got lucky, and one of the first modules he unplugged was under the passenger seat, and the system cleaned up perfectly. He replaced that module, and everything was great. Teaching the student to look for the mirror image is an important concept. This is where you need the 2-channel oscilloscope. You don't need 4, you don't need 6, you don't need 8, and some of these oscilloscopes are way more fancy than you really need. But by the same token, you can't do this with a U-scope, because if you try to do it with a U-scope, you only have one single channel. You can't put 2 U-scopes on top of one another, because you will never get the time base to be exactly the same, and as a result, it won't look like a mirror image. You've got to use a dual trace, and a dual trace will give you the right information. Okay, good or bad. The last thing that we do is we switch over to a scanner. And once we've switched over to the scanner and we plug it in, see what the scanner here says, requesting module status from a vehicle. What is that really saying? Okay, it's asking the modules, or it's pinging the modules. It's waking the system up. It's putting into the gateway a signal, so the gateway will respond by actually sending out a wake-up signal. Okay, and you're asking some basic questions. Is anybody listening? Is anybody talking? Is anyone having any problems? And it means in terms of DTCs. Once the roll call is complete, then module status shows the number of modules. Now, I've kind of cheated here, and this is a real simple car. I'm on the high speed, by the way. It only has 5 modules. That doesn't work as well with some of the new cars. But once the roll call is completed, it indicates that some communication is occurring. Okay, that's the important thing. In this particular case, we have 5 modules. So those 5 modules, and obviously one of them has a DTC, which is the radio, and I usually tell students I really don't care about that, but you know, it was something that you would want to investigate. So what do we do now? Well, the scanner says that the gateway has indicated there are 5 modules. So then the next thing we do is we switch over to the wiring diagram, okay? 2008 Solstice is absolutely the simplest CAN bus car in the world. Use it, okay? Back again, how many modules? 5. So we go over here and we count with the students. 1, 2, 3, 4, 5. So what we have is, on this system, we have the system saying, first off, I had 60 ohms, meaning there is a pathway. Secondly, I was able to measure that. And secondly, after I measure it, I'm able to determine that there is a pathway, and then I see if I have a wake-up signal. Once I determine I have that wake-up signal, I look for the mirror image. Once I'm done with the mirror image, I switch over to a scanner so that the scanner can give me an indication of module status. And when I'm done with that, I'm done. Now, you know, let me get out of this, if I can. Okay. Is that off the screen, Jimmy?
No.
No, we're still on a picture of the 1918. Now we're
There
on.
you go.
Okay, thank you. Okay. With 2 minutes to spare, that's the simple procedure. It's not difficult. It's a very, very easy procedure, and it's something you can teach. You can teach, you know, in a demonstration mode. I mean, it's real easy to sit alongside the car and use a camera or whatever and do all this stuff, because it's all being done at the DOC. And that was my original idea when I came up with this procedure. It was to try to simplify it from an education standpoint. It's not exactly how GM, Ford, Chrysler, Toyota, Honda, or anybody else actually teaches the system, but it's a good way for you to teach it in your classrooms and in your labs, and hopefully online, so that students can figure out what's actually going on.
Al, have
Okay.
you come across a scan tool that does not have module roll call?
Yes, the real cheapy, you know, less than $100 OBD only ones. But anything else has got module status on it. You know, any of the ones you're probably using in a classroom, they have module status. You might not call it module status, by the way, but it's there. Crickets. Ooh.
Hey, Al, this is Tim.
Yes, Tim.
When one of your steps where you unhook the battery to check terminator resistors, that doesn't disturb any evidence, doesn't, like, you know, trample through the crime scene or anything by doing anything by removing the battery?
Well, you know, when I teach this in a full-blown class, I always say, now the first thing we want to do before we disconnect the battery is we want to write down all the DTCs and any indications that we have. Because yes,
Okay.
when we're going to pull it, we are going to trample through the crime scene, as you said.
Okay. Just
But
curious.
all that information is in the handout and the PowerPoint.
Yes, The PowerPoint is not the hands-on variety. I never put that one on. I guess I could, but the handout that's there started out as the 3-hour class that we taught originally, I think, in Florida, Dick, and that was the first time I did it. So it's a full-blown. It's got theory in it. It's got a bunch of different things. It's got information about other systems. It's got full-blown low-speed diagnosis, full-blown high-speed diagnosis, and then goes into this simple procedure. And it also has some case studies. So it's a full 3 hours if you want it. And then, of course, the handout does not have any case studies in it, but has all of the pictures that I used today, or all the diagrams.
I am going to stop the recording. That doesn't mean we're done.